Hello and welcome to another daily Leetcode challenge. Let's begin question 673, number of longest increasing subsequences. Given an integer array nums, return the number of longest increasing subsequences. Notice, the sequences has to be strictly increasing. Okay, so we are given an integer array, a non-sorted integer array, and we have to figure out the number of longest increasing subsequences. So if this was the number of longest increasing subsequences, if we were to figure out the longest increasing subsequence, we would do a DFS and find the longest increasing subsequences. Here we have to find the number of longest increasing subsequences. So there could be a number of them. Okay, let's look at an example to get a better idea. So far I'm still a bit confused, but the input, for example, are nums, where the sequence or the array is 1, 3, 5, 4, 7. And the output is 2. There are 2 longest increasing subsequences. And those would be 1, 3, 5, 7, and 1, 3, 4, 7. 1, 3, 4, 7, and 1, 3, 5, 7. Okay. Interesting. So I think this is a dynamic programming problem. Because a longest or a length of a sequence can be recursively defined as, if there was another number to be appended to this, it would be the longest, the number for that, the length of that longest subsequence would be what is the next, what is the max length out of the given numbers that that are after it. What is the, okay, so sorry, let's have a DP array and say that this DP array holds the max length a subsequence can have starting from current index. So each number, each sequence starting with a specific index can have the longest, can have a max length. A sequence, if another number was to be added to this input array, we would say that its length is the max out of all of these lengths, given that the number is smaller than these values here, because it has to be strictly increasing, plus 1. So with that, I think we are ready to kind of at least define the first part of this problem, and that is I need to find what is the max length I can have of a subsequence starting with each of the indices. So I'm going to pre-fill my array of DP with 1s, like as such, and then I'm going to say that actually for I in range, let's reversed range of n, I'm going to say that right, so just for context, this is to make this return 0. I'm going to be printing numbers from last index to first, and then since I am I have to see 0, 1, 2, 3, 4. I have to see what is the, for each new number that I'm exploring, I have to see what are already some of the possible lengths that I could inherit from a number that is greater than me. So for example, if I'm looking at 5 now, I would skip this because this would not make the subsequence increasing, and then I would look what is the length of 7, and length of 7 is going to be 1, and I would say that the length of max subsequence of 5 would, starting from this integer, would be 2, because this plus this equals 2. Okay, so perfect. So what do I have to do then? I have to say for j in range and starting with I all up until n, I'm going to be looking at, these are the indices in order that I'm going to be looking at. So 4, 3, so 4. No, this doesn't give us much. Let me just already do the max len. It's going to be starting off with 0, and I'm going to say that max len is equal to max of max len dp of j plus 1. And then I'm going to say that dp of I is equal to max len, and let me print dp. What I'm hoping I will get here is a what I'm hoping to get here is a list of longest possible subsequences starting from the current index. And I'm already getting something incorrect. Let's see what I'm doing here. Max len. So I'm traversing I'm traversing the nums from back to front, and as I'm doing that, I'm saying first, what is my max length given from dpj plus 1? Oh, and of course I have to be saying if nums I is smaller than nums j. This is the only way my algorithm is going to know that the max length can only be calculated if the subsequence is increasing. And so now I get something meaningful. My standard out is showing that I have an array that indicates what is the longest length what is the longest length of a subsequence starting at a given index. And this seems to be correct to me. For the 7, the longest subsequence is 1. For 4, it's going to be 2. For 5, it's also going to be 2, 5, 7. For 3, it's going to be 3, 3, 5, 7, or 3, 4, 7. And for 1, it's going to be 4. Okay, and so this is the first portion of the algorithm. Let's go over what it does here and how it does that. We have 2 for loops that the outer for loop iterates over the nums input from back to front. The inner loop starts at the outer loop's index and always goes till the end. What that allows us to do is for each index, as we're exploring it from back to front, we're looking at all the values that we've already looked at and finding out if the subsequence would be increasing, what would be its length. If the subsequence would be increasing, what would be its length? Max length is equal to max length plus dp of 1. Okay, so now that we have this, we're kind of getting a little bit more into the solution here. So the question is, given the integer array, return the number of longest increasing subsequences. Well, what would be the number of longest increasing subsequences here? For the longest subsequence, we know, is of length 4. But how many different ones are there? Well, we can see that to get 2 here, to get the subsequence of 2, there were 2 possible paths. There was 4, 7, and there was 5, 7. And that means that for 3 of length, to find a subsequence of length 3, there would also be 2 possible solutions. There would be 3, 5, 7, and 3, 4, 7. Same goes for 1. So I'm thinking that there's got to be a another array that we define that's going to keep track of those lengths. Initially, they all start at 1, but as time goes on, we need to be seeing if current count, and let's, what would this be? Occurrence, or what does this really represent? Occurrences of lengths, or max occurrences. Says, let's call it 1. And what is an occurrence of a max? So I'm thinking that as we're iterating over this array, for example, to calculate 3, we would have to see how many different ways can we get this 3. Well, we can get this 3 by looking at this value, or we can get this 3 by looking at this value. So if my index is fitting the profile of being smaller than the values that I'm looking at, I'm going to have a condition if max length is equal to dpj plus 1, then I have encountered another instance of me looking at a path that I can use, in which case I would be saying occurrences plus equals 1. If max len is smaller than dp of j plus 1, then in this case I update my max len to be dp plus j. And what do I set this back as? Do I set it back at 1? Equals to 1. Let's see what this returns. Print dp, print count. Oh, and I'm never setting the occurrences. So count now at a specific index is going to be the occurrences. Let's see what this count now holds. It should be printing out that the way to get 1 here is only one type of way. I can only see 7. The way to get a 4 here of max of length 2 is only once. There's only 4, 7. The way to get 5 of length 5, there's only one way. That's 5, 7. To get 3, I have 2 possible ways. I can get 3, 5, 7, 3, 4, 7. This is exactly what we want. 3, 5, 7, 3, 4, 7. And finally, to get 4, okay, so this is wrong. To get 4, this should also be 2. because to get 3, okay, so actually, I guess if I'm seeing a max length smaller than dp plus 1, I should be setting this to count of j. Perfect. Okay, so now that we have this flushed out, to get 4, I actually inherit the number of ways I can get it because I'm using this value. Okay, so now that I have, and for 222, there's only one way to get a max length of 1, which is 1, 1, 1, and there's only one way to get each. Okay, so perfect. What was the answer for this? The answer for this was 5, because the length of the longest increasing subsequence is 1, and there's 5 increasing subsequences. So, okay, so now I have to figure out what is the, okay, it's easier to look at, what is the max value in this, what is the max value length? And I'm going to say that m is equal to the max value length, and I'm going to say that m is equal to max dp, and then for each variation c in count, I'm going to say if no, this is just going to be I range n, for I in range n, if m is equal to dp of I, I'm going to say the what is this, num is equal to 0, and I'm going to say num plus equals count of I, and I'm going to return num. So this works. Awesome. Okay, and there we go. We broke up the problem into little steps and solved it bit at a time. Let's see if this works. And I have a wrong answer. Wrong answer. Let's use this test case and try to run. See what is happening here. So my output is 2, as in there has to be an increasing subsequence of length, let's see, 1, 2, 3, 4, 7. 1, 2, 3, 4, 7. That's of length 5. 1, 2, 4, 5, 7 also works. 1, 2, 3, 5, 7. 1, 2, 4, 5, 7. 1, 2, 4, 5, 7. 1, 2, 3, 5, 7. What about 1, 2, 3, 4, 7? So there are 3 exceptions. Okay, let's print, see what happens. What's going on? dp print count. So there's one way to get a 2. There's one way to get a 7. There's one way to get a 4. There's, okay, sorry, but all of those were also just of length. This was of length 1. This was of length 1. This was of length 2. This was of length 2 as well. This was of length 3, supposedly. 3, 5, 7. Yeah. And is there only one way to get it? No, there's supposed to be 2 ways to get it. There's 3, 5, 7, and 3, 4, 7. That's correct. What's the next one? 4, 3, 4, 3, 5, 7. 4, 5, 7. 4, 5, 7. that is of length 3, and there's only one way to get it. And for the next one, there is of length 4, so 4, 2, 4, 5, 7, 2, 3, 5, 7. So there's supposed to be 3 here. Should I be adding up the count? Should I be adding up the count rather than just... Wait, if I've encountered another max, then I should be adding up. Okay, there we go. Okay, so what was happening here is, okay, before this was here, let's go back to what this was actually. What was happening there is I wasn't accumulating the number of occurrences from this 4. So from this 2, the question is how many different ways can I get that longest path? And previously, I'm looking at these 3s, right? Because I'm a 4 right now of length 4, but I have these 3. And look, the sum of these isn't equal to, sorry, this isn't equal to the sum of these, but it should be. It should be the sum of the 3 previous maxes. And so max length is equal to dp plus 1, but why am I only adding 1? I should be adding count j. I should be taking into account both of those instances. Only in the case where I meet a new instance, for example here, do I say that, yes, you are of the same type, you're of the same variation. There's only 2 possible ways to start from here and go all the way through getting the length of 5. But if I am of length 3, 4, and there's 2 other paths that I can take, then that should be the sum. So this is the sum, and this is the adoption. So, yeah, let's see if this works. And woohoo, there we go. And we beat a good number of people. There seems to be still a wide range of better solutions. Let's see, maybe there's some faster ones, but 92 is really good. What is this huge spread? So that's my solution. Let's look at a little bit something that's more concise. This one only has this one has the same approach. There's 2 nested loops, and then there's that condition. How are they doing this so much faster? Don't know what those are. Find positive. Let's look at the best. For nums and nums. Okay, I don't know what these are doing here, but it seems like they're still operating on the same idea that there's a dynamic programming array that we're building up with these counts and lengths. And yeah, I would probably just say use this approach because it's more explainable and probably easier to read for all of you. So and for me too as well. So okay, yeah, I would recommend this. And cool. All right, well, thanks for watching. Yeah, this was on the harder side, but breaking it up into small pieces really helped. So hope this helps, and thank you so much for watching. See you later. Please like and subscribe. Bye.